Hello friends, let us do one problem from the portion electrical conductivity. A uniform copper wire whose diameter is 0.16 centimeter carries a steady current of 10 ampere. Its density and atomic weight are respectively 8920 kilogram per meter cube and 63.5 gram. Calculate the current density and the drift velocity of the electrons in copper. So we are given with a set of values. We have to substitute the values in the known equations to find the current density and the drift velocity. So let us have a look at the variables that are given. We are given with a diameter which is 0.16 centimeter, and this implies that the radius, which is diameter by 2, that will be 0.08 centimeter, which is 0.08 into 10 raised to minus 2 meter, which will be 8 into 10 raised to minus 4 meter. And then we are also given with the current, so I equal to 10 ampere. Then we have the density. So density is 8000. So let me write rho equal to 8920 kilogram per meter cube, and the atomic weight, which we call as m, atomic mass, is 63.5 gram. So we are given with density and mass in order to find the charge density n. So in the last problem, in one of the problems, we saw the equation, the charge density n equal to rho into Avogadro number Na divided by the atomic mass m. Multiply this with the valency to get total number of free electrons. So using this equation, let us substitute. Density is 8920. Avogadro number is 6.022 into 10 raised to 23, and atomic mass is given by 63.5 gram. So 63.5 into 10 raised to minus 3 kilogram. So actually we have to multiply this with 2, since copper is Cu2 plus and 2 free electrons are available per each atom. But since your textbook does not use that multiplication factor with 2, let us skip that. So according to the concept that we have developed, this number should be multiplied by 2. But that will only bring a very small change, the factor of 2 change. So let us follow the textbook, and we are omitting this term of valency. So as of now we have got the charge density, which is n, and we can solve this and find the value of n to be equal to 8.46 into 10 raised to 28 number of charges per meter cube. So this is the total number of charges available per unit density. So we have all the terms that are required here. We have the radius r, from which we can calculate the cross section area. We have the current I. Then we also have the charge density n. So first of all, let us move into the first part. We have to determine the current density, which is given by current per unit cross section area. So there is a 10 ampere of current as given in the question, and the cross section area is pi r square, which is pi into 8 into 10 raised to minus 4 the whole square. So this can be calculated to be equal to 4.97 into 10 raised to 6 ampere per meter square. So this is the current density. So first part of the question is solved. We have to calculate the current density, and the second part is to calculate drift velocity, and we require n while calculating drift velocity. So what is the equation for drift velocity Vd? The equation connecting current and drift velocity is given by I equal to cross section area into drift velocity multiplied by total charge density into E. So this is the equation connecting current and drift velocity. So what will be drift velocity? It will be I by area into N into E. So we have already calculated I by A, which is J. So drift velocity will be J by NE. So we know the value of J and N. J is 4.97 into 10 raised to 6. And N, from the previous calculation, we know the value of N. So N is 8.46 into 10 raised to 28. And the charge of electron is 1.6 into 10 raised to minus 19. So use your calculator to find this value. You can actually find the value of drift velocity to be equal to 3.67 into 10 raised to minus 4 meter per second. So this is a very small value, you can notice here. Actually, electrons drift through a metal piece at a very small rate, 2 or 3 millimeter per second, or here it is 0.3 millimeter per second. So drift velocity is a very small value, and this is how we solve this problem. All we need is some basic equations, and here this is a commonly used equation in most of our problems. If density and atomic mass are given, we have to use this equation to find the total charge density. Other equations are just substitutions and basic equations. I hope you understood solving this problem. Thank you.